Good day, everyone. I am Alvin Bohol, and welcome to Data Communication and Networking 1. So, with the topic of IP addressing and subnetting. So, today I will teach you how to convert the network address to binary, how to convert prefix length to subnet mask and vice versa, and how to identify the three types of addresses. So, let's start with our first problem. So our first problem is to find the prefix length and the broadcast address. So using these details. So to find the prefix length, we need to get the binary number of our subnet mask, which is this one. So we need to get its binary number. Okay, so 255 255 that 244. So this is a table of conversion on how to convert a decimal to binary or vice versa. So from binary to decimal. So now our next process is to find if there is 128 in this value. Okay. So how many 128 are there in 255? So 255, so there's only one 128, right? So put 1. So next is we need to subtract 255 by 128 to get the recent value. So our recent value is 127. So is there 64s and 127? Yes, there is 1. So next, 127 minus 64. So our current or recent value is 63. So how many 32s are there in 63? Okay, there's only 1. So 63 minus 32, so we have remaining decimal of 31. So how many 16s are there in 31? Only 1. Okay, so 31 minus 16. So our recent or current remaining decimal is 15. So how many 8s are there in 15? Okay, only 1. So 15 minus 8, we have 7. So how many 4s are there in 7? Okay, only 1. So 7 minus 4, we have the remaining decimal of 3. So how many 2's are there in decimal 3? Okay, 1. So 3 minus 2 is equals to 1. So how many 1's are there in 1? So 1, of course 1. So next, so since they have the same decimal, so we put here what? Okay, this one. Then let's solve it, the last decimal, which is the 244. So the same process. So how many 128 are there in 244? So there's only one. Okay. So 244 minus 128. So our remaining decimal is 116. So how many 64s are there in 116? So we have 1. So 116 minus 64, we have 52 remaining decimal. So remaining decimal, how many 32s are there in 52? So only 1 again. So 52 minus 32, so we have 20. So how many 6s are there in 20? Only 1. So 20 minus 16, we have 4. So how many 8s are there in 4 decimal? None, 0. How about in 4? So of course 1. So 4 minus 4, 0. So since there is no remaining decimal, we put the value here as 0 and 0. So now, this is the binary value of our subnet mask. Okay. Now, remember that the ones here in the table are the network portion and the zeros are the host portion. So counting all these ones here in the table is our slash portion or slash notation or the prefix length. So counting this 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 3, 24, 25, 26, 27, 28, 29. So therefore, our prefix length is 29. Now let us find the broadcast address. So to solve the broadcast address, we just need to subtract our subnet mask from the maximum subnet mask portion, host portion. So this is 255 minus 255 minus 255 minus 255. So this is the maximum host portion of a subnet mask. Okay. So then minus our current subnet mask. So the same 225, 225, 225, then 244. Okay. So 0 dot 0 dot 0 dot 11. Now this is our host address. So to find the broadcast address, we need to add this host address to our network address. So plus 0 dot 0 dot 0 dot 11. So 172 dot 201 dot 95. So 32 plus 11 is 43. Therefore, our broadcast address is 172.201.95.43. Okay, so here is our final answer. So our prefix length is 29. Then our broadcast address is 172.201.95.43. So for the next problem is we need to find the subnet mask and the gateway address. Okay. So to find the subnet mask and the gateway address, so let us first this. So to find the subnet mask, we must convert our prefix length into binary. So what is our prefix length? So our prefix length is 25. So this is our prefix length, and we know that prefix length is equals to the number of bits of 1 bits or so therefore 25 is equals to 25 ones bit and the remaining bits are 0. Okay. So it's equals to 1, 2, 3, 4, 5, 6, 7, 8. That 1, 2, 3, 4, 5, 6, 7, 8. That 1, 2, 3, 4, 5, 6, 7, 8. That 1. 1, 2, 3, 4, 5, 6, 7. Okay. So this is our the binary of the prefix 25. Now to get the subnet mask, we need to convert this binary into a decimal. So let's transfer this here. So 1, 1, 1, 1, 1, 1. Okay, the value of 1. Wait, this is 0. 0, 0, 0, 0, 0, 0. Okay. Now, to get the subnet mask or to convert this binary to decimal, what we need to do is to add the value of this. Okay, so the value of 1 is 128, the value of 1 is 64, the value of 1 is 32, the value of 1 is 16, the value of 1 is 8, the value of 1 is 4, and so on. So adding this as the value of our ones, we have a total of 2, 5, 5. So the same with the second decimal, 255, and the third one, 255. How about the last one? So since there is only one who has a value, then we will write 128 here. Therefore, this is our subnet mask. Okay, so this is our subnet mask 255.255.128. Now to find its gateway address, so we know that the gateway address should always be the first usable IP address. So here is our network address. So our gateway address should be this one. 10.10.78 dot 129. Okay, so this means that the first usable IP address is 10.10.78.129. Okay, so for our complete answer, here is our final answer. Okay, so our subnet mask is 255.255.255.128. Then our gateway is 10.10.78.129. Okay, so for the next problem, we have this one. So we need to find the binary of the IP address and the broadcast address. Okay, so what is our IP address? 192.84.235. So 192 is this 84235 84235 0. So the same process with our previous solution. So we just ask if how many 128 are there in 192. Then subtract. So 192, how many 128s are there in 182? Obviously, there is only one. So 192 minus 128, so our remaining decimal is 64. So how many 64s are there in 64? It's only one. So 64 minus 64 is equal to 0. Then automatically this value will become 0 as there are no remaining decimals to be subtracted. Okay. Then for the 84. So how many 120s are there in 84? So if none, we put 0. How about in 64? Okay, yes, we have 1. How about, okay, so 84 minus 64, so our remaining decimal is 20. How about 32? No, 0. How about 16? Yes, there is. So 20 minus 16, our remaining decimal is 4. So how many 8s are there in 4? None. How about this one? Yes, there is 1. So 4 minus 4 equals to 0. Then this is going to be 0 and 0. Okay, so How about the 235? Next, so how many 128s are there in 235? So there's only one. So 235 minus 128 is 107. So we have 107 remaining decimal, 107. How many 64s are there in 107? There's only one. So 107 minus 64. So our remaining decimal is 43. How many 43? How many 32s are there in 43? So we have one. So 43 minus 32. So we have 11. So how many 16s are there in 11? So none. How about in 8? Okay, there's one. So 11 minus 8, we have 3. So there are 0 fours and 3 decimal. How about here? How many twos are there in 3? So we have 1. So 3 minus 2 equals to 1. So how many ones are there in decimal 1? 1. Okay, our last digit is 0. So since this is 0, so the value of course here is 0. Okay, so therefore the binary address is of 192.84.235.0 is 11000000. That's 01010100. That 111010111. That's 00000000. Okay, so that is the binary. Okay, let's try 1000 six, 0100. Next 1110101. That 0. Okay. Now let us solve the broadcast address. So the same process, we need to get the maximum subnet mask host portion and the maximum and our current host portion. Okay. So our subnet mask is 0. Host portion is 0. So two. Okay. So our subnet mask here is 0. So let's subtract this one. 0.0.0.255. So our host address is 0.0.0.255. And to get the broadcast address, we need to add this one to our network address. Okay? So this is our network address plus 0.0.0.255. 0.0.0.255. So we have 192.84 that 235 that 255. So our broadcast address is 192.84.235.225. Okay? So this is our final answer. Okay, so here is our binary of the IP address 192.162.350.20 and our broadcast address is 192.84.235.255. Okay. Now for our next problem, this one. So find the prefix length and the broadcast address. So again, to find the prefix length, we need to get the binary number of our subnet mask. So what is our subnet mask here? 255, okay, 192. So 192, 255, 255, 255. So in our previous solutions, we know that the value of 255 in binary is 1, 1, 1, 1, 1, 1, 1, 1. So we just need to put here to save time. Okay, this one, this one, this one, this one. And now let's solve with the 192. So the same process, we need to ask if how many 128 are there in 192. So of course, there's only one. So 192 minus 128, our remaining decimal is 64. So how many 64 are there in 64? We only have one. So 64 minus 64, 0. So we need to say it's going to be 0. Okay. Okay. Now, to get the prefix, we need to count this one. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3, 24. 25, 2 times 34. Our prefix length is 26. Okay. So next is the broadcast address. So the same process. So our maximum subnet mask host option is 225.225 that 22 no, that's not 225, it's 255. 255, 255, that 255. So our subnet mask here is 192. The same, that 192. So subtract 0, that 0, that 0, that. So 255 minus 192, we have 63. Okay. So our host address is 0.0.0.63, and to get the broadcast address, we need to add this host address to our network address. Okay. Plus 0.0.0.63. Okay. So 172.184.64 plus 63, 127. So therefore, our broadcast address is 172.99.184.127. So for our final answer here is our final answer. So our prefix length is /26 and our broadcast address is 172.99.184.127. 192.168.127. Okay. Now for our last problem, we have to find the binary of the IP address and the broadcast address. Okay. So to find the binary, okay, what is our binary here? Address 205.36.72.56. Okay. 205.36.72.56. Okay, so the same process again. So there is 128 and 205. So 205 minus 128, our remaining decimal is 77. So how many 64s and 77? There is only one. So 77 minus 64. So our remaining decimal is 13. So how many 32s? No. And 13. None. How many 16s and 13? None. We put 0. How many 8s and 13? 1. So 13 minus 8, we have 5. So how many 4s in 5? 1. So 5 minus 4 equals to 1. So how many 2s in 1? None. How many 1s are there in one decimal? 1. Okay. Now for the 36, the same. So how many 128s in 36? So none. How about 64? None. How about 32? 1. There is 1. So 36 minus 32, then we have 4. How many 16 and 4? None. How many 8s? None. How many 4s and 4? Then 1. So 4 minus 4 is equals to 0. Then it's going to be 0 as there is no decimal value to be subtracted. Okay. Next is 72. Okay, 0. So is there 64 72? Yes, there is 1. So 72 minus 64. So we have 8. So remaining value for decimal is 8. So how many 32s in 8? So none. How about in 16? None. How about in 8? So 1. So 8 minus 8? 0. 0 and 0. Okay. Now for the last decimal, we have 56. So the same process. So is there 128 in 56? None. Is there 64 in 56? None. Is there 32s in 56? Yes, there is 1. So 56 minus 32, we have 24. So is there 16 and 24? Yes, 1. So 24 minus 16, we have 8. So is there 8s in 1? In 8? Decimal? Yes, there is 1. So 8 minus 8 is 0. Then it's going to be 0. Then it's going to be 0. Okay. So, So this is the binary value of our IP address 205.3672.56. Okay. So we have 11010101 dot 0, 0, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Then 0, 1, 0, 0, 1, 0, 0, 0. Then 0, 0, 1, 1, 1, 0, 0, 0. So this is the binary value of the IP address 205.36.72. 5, 6. Okay, so now let us try to solve this broadcast address. Okay, so the same process. So our maximum subnet mask host portion is 255. Okay, minus what is our IP address? Subnet mask 248. The same 248. Okay, so 0.0.0. So 255 minus 248, we have 7. So this is our host address. Then we need to add this to our network address to get the broadcast address. Okay, so we need to say we have 205, 56 plus 7, 63. So this is our broadcast address. Okay. So for our final answer, this is our final answer. So our binary of the IP address 205.36.72.56 is 1101.001.001.001.001.001.001. And our broadcast address is 172.99.184.63. So this is our final answer. So I hope you have learned how to solve or how to convert the binary of the IP address, how to get the broadcast address, how to convert the subnet mask to prefix length, vice versa, and that's it. Thank you for listening.